Good morning to all. Myself Felix Mudiyappan, working as assistant professor at St.Xavier's Catholic College of Engineering, Chungangadai. Myself teaching thermodynamics to students. So in this video, let us see some important aspects of thermodynamics. When we say thermodynamics, we can split the term into two, that is thermo and dynamics. So thermo means heat, dynamics means movement or work. So in between there is energy, that is in order to produce movement we use heat energy. So this is the thermodynamics. The term thermodynamics meaning of the term thermodynamics. So generally when we say thermodynamics, it is an universal subject. It's a part of principles or working of our universe. So there are general assumptions initially we should know when you study thermodynamics. Rather than roughly studying what is thermodynamics, we should know on which basis the subject is developed. So first of all, there are general assumptions are there. That is thermodynamic equilibrium is the one of the assumption. That is, when a system is said to be thermodynamic equilibrium, it means thermal equilibrium, mechanical equilibrium, chemical equilibrium and phase equilibrium. So here in thermodynamics, we take statistical average of group of molecules. We call it as state properties. Okay, that is microscopic approach. Also we assume continuum approach. The things are continuously existing. For example, if we take a gas, we assume that it is continuous, not dispersed. Okay, so individual properties of atom molecules and we are not taking into consideration. This is the second assumption. Third assumption is perfect or ideal gas equation. That is, this follows the thermodynamics working fluids follow the law PV equal to nRT, where R bar is the universal gas constant. When we simplify this, we will derive PV equal to mRT. This is ideal gas equation. This is the assumption. And pure substance assumption. When we talk of the fluid working fluid, it should be a pure substance. So for pure substance, there are specifically we have developed tabular columns, there are steam tables, like that. We have water is one of the main pure substance. A pure substance definition, if you see the definition of pure substance, it is a pure substance can be perfect gas or not perfect. Perfect gas can be pure or cannot be pure. Okay, similarly perfect gas can be pure or cannot be pure. Pure substance means definition. What is the meaning of the pure substance? It means it's homogeneous in chemical composition, chemical aggregation. There is no change. Okay, that is the meaning of pure substance. This is the fourth assumption. And system and control volume assumption is another assumption. There are still when we come across, we will notice many assumptions. Okay, so next is state functions or state properties or point properties. We come across the terms pressure, volume, temperature, work, energy, power, height, enthalpy, U, internal energy, entropy, S. So and also G and F, Gibbs free functions and Helmholtz free functions. So we call it as G and F as along with H and S thermodynamic potentials. So we should know path functions and process properties. What is meant by path functions? Work and heat are known as the path functions, and power also, because it depends on the path of the system. in case of when we talk of pure substance, I missed to say this is that is pure substance whose superheated steam is perfect gas, but saturated steam is not perfect. So please make note of it. So there are common errors when studying thermodynamics. Students may put these common errors, that is fail to understand definition or important terms. For example, isentropic meaning. What is the meaning of isentropic? Or it is called entropy is same. Isentropic means entropy is same, or reversible adiabatic equal to isentropic. These terms are very important to know, to forget, because in the problem, when you solve the problem, directly they will give it is isentropic. So we should know what the term means. Enthalpy means, what is enthalpy? Enthalpy means heat content. What is system and surrounding? And perfect and ideal gas constant. If what is temperature is not constant, shall we use perfect gas equations? This is one of the main thing students fail to understand. The second is fail to understand notations, units, etc. For example, pressure equal to P, volume is V, its units, pressure unit is Newton per meter squared or bar or Pascal, and volume is meter cube. Specific volume, small v. Should know to differentiate between capital and small letters. Specific volume is denoted by meter cube per kilogram. Temperature, its units is K. So these notations and its units are very important in solving, because when you solve the use an error, students put while solving problems. Then third is unit tally. As I said, LHS should be equal to RHS. Take the equation PB equal to MRT, and we find here LHS equal to RHS. If we put the units for each letters and then simplify it, LHS equal to RHS, we get it Newton meter equal to kilonewton meter. But we should have both sides should be kilonewton meter. So we have to multiply by 10 power minus 3, or you should 10 power minus 3 in the right hand side, or put 10 power 3 in the left hand side. So you have to change this to kilonewton per meter squared. Okay, that is K, add K. This is how we have to do. Mistakes in notations. So I told you there are two types of quantities, total and capital V and small v. Here I said this. So like that we have total quantities and specific quantities. Total in the sense we denote by capital letters H, U, S. It's small only H, U, S. Okay, so try to differentiate this. So specific in the sense it means per kilogram. Try to understand that also. So mistakes in taking formula for specific cases. That is, when we say ideal gas equation, mostly people without understanding R use the R. R is the universal gas constant. Yes. Students also put mistakes in taking formula for specific cases. We have to be very careful in using formula considering each parameters. Okay, the state equation, for example, here in this case, P capital V equal to N R bar T, not R. P capital V M R T. It is not R bar. Okay, here M comes. Also try to understand P small v it is V bar equal to RT, not N and M is not used here. So this understanding should be there. We should not write P capital V equal to N R N R T or M R bar T should not be used. Okay, we can also use PV equal to RT. Okay, so we will discuss later how this equations will be derived and significance of each terms, on which basis this equation derived, we will discuss later. Time being, just understand in mistakes, what mistakes students put in this section. Try to understand, that is, there should not be confusion in using specific cases. Okay, formula. So another thing is then students put error in using the Batmas, without Batmas, using Batmas rule, they solve the problems. Okay, Batmas all of you know, yes, bracket, division, multiplication, addition and subtraction, yes. So we have to follow this rule. This is another common error students put. Being fresh from school, 1 year only passed, that is first year of engineering passed, when they come to second year to specific departments, they have to refresh their school basics. That is very important. Another thing, before studying for exam, very important is not exam, from beginning itself students should know to study from seeing by seeing the syllabus. That is, first unit what are the contents, second unit what are the contents, third unit. So they will specifically know what they are studying and from which they are studying, so there will be no confusion. Okay, so but in case of autonomous institutions like us, syllabus are a bit modified. Anyway, you have to understand the syllabus. I am not giving here. So students should be aware of what they are studying, and they have to link and study. That is very important. Otherwise, it won't stay in their brain or mind. It's very important. So try to follow this for exam. So best of luck. Thank you.